Yeah. Share screen. Get you easy money. Is that Elon? Yeah. Elon took all this stuff. What is that here? Yeah. All right. I think it's not, bro. Yeah, 3 times. Maybe wait like 1 or 2 more minutes. All right, so hi everyone. Happy Monday. Hope you all had a good weekend. Happy Pie Day. Hope you're all eating some pie today. Yeah, so we're in week 9 now. Here's another cool picture taken by our former instructor, Elon. And yeah, the homework 6 was just due, I want to say. Yeah, on animation. Congrats on getting through that. It's a tough homework, and from now on, here on out, I believe we'll have 1 more coding homework, and then the rest of the homeworks will be a little more relaxed. So yeah, don't forget though, project proposals are due this Friday. They need to be latex, which I'll talk about today. And Emily's office hour was just now from 2 to 3. It got moved. And we have new Astro Resources from Claire. And yeah, go ahead.
So do you want to pull up the
Yeah.
So after chatting with some of y'all last class, I know quite a few of you are curious about astro and just physics related like data analysis projects or whatever, or even just simulations, like what kind of crap can you do, right? Possibilities are endless, but something I just wanted to show y'all was some like stuff I've worked with in the past, some stuff I've heard from other people. The cool thing about astronomy and astrophysics is there is so much data out there, whether it's from like telescopes or NASA missions like Kepler and just stuff like that, and all of that stuff is available online for free. So you guys can literally like just go to one of these websites, download something, play with it. Like you might find out, you could literally find like exoplanet candidates by playing around with this data. And just so it's like, just to let you guys know, there's some cool stuff out here. Like there's a website from like Caltech and NASA where it's just a database of like every single exoplanet candidate that's ever been found. So just wanted to bring this to y'all's attention as you start thinking about your final projects and working on proposal and stuff, to check some of these out. There's also some cool libraries for if you want to play with, light curve data, doing a little bit more like specific astro stuff. You want to model how like a planet moves, or, like be able to open data that's literally just a survey of what the galaxy looks like and whatnot. Like that's all stuff you can do. So feel free to check this out. It's under like the resources folder on B courses. Very indicative title there. Yeah, feel free to check it out at your own leisure. Hopefully you'll find it helpful in your final projects. Enjoy.
Yeah, so definitely, I'd emphasize, definitely look at that if you can. It's really great, really useful. It's really incredible, honestly, like Claire was saying, how much you can gauge, like how you can get little real data and find an exoplanet yourself. Like you don't need anything else. So yeah, also, you might be wondering how Claire even made this at all. It looks cool. It has links. The font is nice. So that's what we'll be talking about today. We'll be talking about LaTeX. So, oops, sorry. There we go. So LaTeX is basically a coding language, somewhat similar, a typesetting language, I guess is a better way to put it. That is the staple of scientific writing, essentially. It allows you to write down equations, allows you to collaborate with people. It makes your writing look way nicer. It's really great. It makes your homework look nicer. It allows your GSIs to read your homework and everything like that. This graph is sort of a little bit of a joke, but it's also serious in the sense that LaTeX makes everything easier. You should never be using Word ever again after getting into LaTeX if you're in the sciences. So there is a little bit of a learning curve. I mean, it's sort of a learn by doing type of thing. So yeah, so yeah, basically, as I said, it's a typesetting system. It's code-like, but it's definitely easier than Python. It's somewhat intuitive in terms of like, you're just writing down what you want to appear in symbols and using various commands to make them appear either in the middle of the page or in your text or whatever it may be. You don't see the output while you're writing it. So you write down a bunch of code and then you compile a document in this thing called Overleaf, which is an online LaTeX editor. And another cool thing is that it's really easy for collaborative work. It's like Google Docs. You can comment, you can share it, people can edit it at once. It's just, I can't really say enough about how useful this is. It really makes your life way easier when it comes to doing anything in the terms of the research community, but also, frankly, I know it's in the beginning, it might be a little harder, but it really can make even doing your problem sets easier, like in terms of making them more readable and just easier to understand. So, I mean, mostly, like I said, it's sort of a learn by doing thing. So we'll basically talk about some packages and then go into a demo. So yeah, there's a bunch of packages you can import at the start. There's all these different tools, essentially. You can use a math package, a physics package, but basically Google is your friend here. Definitely always Google things. Frankly, I don't have it memorized what the commands are, for example, to make a figure. So I'll be showing you guys later how to do that using Google, basically. There's all these different websites which are cool. There's Detexify. Basically, you can draw in symbols. I guess I could just show you guys really quickly. You could draw like theta. And it's right here. It tells you the command basically that you want to make the theta appear in your document. But this will all become a little more clear as we get into it. So that's what I'll do now. I'll open overleaf.com. Yeah. I'll open a new project. I'll say just for now, let's have it be a blank project. Let's call it Python Decal demo. You create it. And then here we go. Automatically it loads in. It looks like this. It has a document class. It has a package, which is the standard package used in LaTeX. You can change this. You can have a bunch of stuff here, which can classify how exactly you want your document to look. But for the purposes of an intro, if you guys want to go on your computers now and try to mimic what I'm doing, that'd probably also be useful. So yeah, so here you set the title. Everything is in LaTeX is to do with backslashes. So whenever you want to set something like a title, a section name, an equation, you essentially always want to be using these backslashes. So the author, instead of my username, I could just put my own name, the date, yeah, and then you have to put a begin document and then make title so that your title basically renders, and everything should come after that begin document, and then you can start making like the sections and subsections of your paper. So you could have a section called an introduction, for example, where if you wanted to, you could say, here's an equation. And in order to write an equation, if you want it to appear in the text, you use $2. You say E is equal to MC squared, like that. You recompile, and it appears right there. So you see, it looks different in terms of the letters are italicized, essentially, once you put them in the $signs because you want to do math. This becomes sort of more useful, I guess, if you want to say like pressure is equal to force over area, for example, where you could do a backslash frac, which makes it become a fraction, and then using these curly brackets, you could put F and A, and now instead of having to do sort of an ugly slash sign, it becomes a formula very clearly, like so. Yeah. Yeah, there we go. So yeah, so basically you can make easy fractions, you can do integrals, you can do sums, you can do any type of math essentially in LaTeX like this and in Overleaf. So you might be wondering, it's nice to have it in here, but what if I'm writing a paper where I want it to appear in the middle of the page, for example? So to do that, you use double $signs. So essentially you go like this, and then you recompile, and you'll come into the middle of the page and it'll be centered. And this is way nicer. It's easier to read. James likes to nag me about not doing this, and I definitely should do it more. But yeah, it's important to remember to always do this because yeah, it is harder to read if there are a bunch of equations in your text intermittently rather than having them centered like this. Now, if you want to keep track of your equations, you could do something like this, where you could go begin equation, just like we did begin document, and then you would do end equation at the end, and then you put this in the middle, and you go like this, recompile, and now the equation is numbered. As you can see, there's a number 1 on it. Yeah, and then that's basically how you do equations, which is mostly what you'd be doing in LaTeX as a scientist. Another important thing is to make other sections or subsections. So you could go like this, make a subsection, part 1 or something like that, whatever you want to call it. And then becomes 1.1. And then just to make a new section, you could just go, I don't know, say you're writing a paper, you want to write your methods down. You do section methods, and that becomes section 2. So before I move on a little bit, if anyone's doing this, anyone have any questions or anything like that? Yeah. Okay, so I'll just keep going then. Once we've done, so now we've gone over how to make an equation, how to make sections. Essentially, this is sort of the bare bones of LaTeX, but it's also, you're not going to need that much. As you can see, like just using these 3 tools, I could basically write an entire report right now. But say, for example, we wanted to include figures. Now, figures are a little bit different. Frankly, I don't remember off the top of my head how to include a figure, so that's why we use Google. So we go include figure, LaTeX, inserting images. You go to the Overleaf help part. You can go here. I mean, you can use the graphics path, but I think it's easier, yeah, to do. Yeah, exactly. You can go include. So basically, what you would want to do is you want to go begin figure, and then you go, yeah, and then it immediately knows what you want, basically. So it'll put all that in. I didn't type any of that clearly, but it centers it. It includes graphics. So if we want to put anything in, I would upload. I don't know, what do I have here? I have a light curve of a supernova. So this is called 2017 EAW light curve, I think, .pdf. So you can insert PDFs, PNGs, any type of file, basically, and you can put a caption. Wait, it's saying it doesn't. I'm not sure if it doesn't know what the figure is. Oh, at the top, yeah. Yeah. Let's see. Yeah. So that's important. You have to include the package that allow graphics essentially to render. So here we go. I mean, yeah, the one thing with LaTeX is it often formats your images a bit strangely, like it makes this really big, but you can play around with that. As you can see here, you could like change the width and the height of the image. So you could do like, instead of making it do it arbitrarily, because LaTeX doesn't really know what you would want potentially, you could make it 5 by 4 centimeters. And in that way, you're able to make it way smaller. Obviously, that's a little small, but you could change it around to something more reasonable, like 10,8. And now it'll appear like this. Looks a little bit stretched out, so obviously I'd want to change it again, probably. But sort of the point of this is, regardless of what the image looks like, is you can just play around with it as much as you want until the image looks how you want it. You can caption it with the name of the supernova and say light curve or something. And then it'll be labeled as that throughout the rest of your paper or whatever you want to do. So yeah, basically these are I would say the 3 essential elements you need to making an Overleaf document and sharing it and collaborating. And most importantly, to make your project proposal, basically, you'll need images, you'll need equations, you'll need sections, but also for your project proposal, you'll need to share and work with each other. So to do that, I'll show you guys how we do that. And I'll open, let's see, this is my lab for one of my lab classes. And for example, I could share it with James Sunseri at berkeley.edu. But now I've reached the maximum number of collaborators, but I believe James should still be able to edit it if you go on. Because yeah, they basically want you to join them to have more than 2 collaborators, but usually you can sort of figure it out. I think.
Also, if you make it with your berkeley.edu,
Yeah.
you should have like a pro profile so you can collaborate with me.
Yeah, so as you can see now, I can see that James is on the document, and this is how you can tell who's on it, basically. You can have a lot of collaborators, and they can all be working at the same time. I can click his letter to see where he actually is in the source itself before compiling it. And James can provide comments or just edit once they're a collaborator, basically. So yeah, it's just basically a super useful tool that you can use to work on physics with other people.
Recompile and go to the abstract.
Yeah, there we go. So James wrote, "Check me out, y'all," and now it appears right there. And yeah, so basically you can edit it. You could also just provide comments. There's ways to sort of give your own signature if you want to provide comments on something, but you don't actually want to edit it. There's ways to do that, like in Google Docs. It's essentially a far more advanced Google Docs if you really get down to it. You can share it, you can edit it, you can write anything you want. You could also just write an essay if you didn't want to do any math in this, and there's ways to make it look really nice. I can show you really quickly. If you go to Overleaf, you can make new project, and instead of choosing a blank project, you could choose a template where you have like you could make, for example, something like a homework assignment. So you could do like this, and this will give you a template where you can open it. And now they have all these packages loaded in that'll make it look basically a certain way. You can choose, from, as I was just showing you, you can choose from a variety of templates. And now it looks like this, and all this stuff is loaded in, and you can change obviously all this. So I could change assignment to what class and whatnot. But the point is, they have all these templates already built in, so you can make your stuff look nice without you having to do any work, essentially. So yeah. So that's basically most of what there is. I mean, there's obviously way more. You can make tables, etc. But basically, this is, like I was showing you, learn as you Google type of thing. Like, keep Googling, keep looking. If you have any questions, let us know, obviously. But most of the time, it's just a matter of repetition and figuring things out. I mean, basically, yeah, I guess one thing I could show you also really quickly is if, like, you can make basically different symbols. Like I was showing you that detectrify document, you can make like a theta right here, and always using the backslash in the dollar signs will let it render in its math form, essentially. So yeah, basically this is how we use LaTeX, and now we want you guys to start doing it. Basically, just work on your project proposals for the rest of this class. Let us know if you have any questions about the projects, about LaTeX, about whatever, about group members, etc. So yeah, just get into your groups and we'll get started working.
Why don't we use the same kind of like layout last time? So I think we had groups like 1, 2, 3, 4 at each table over here, and then I think 5, 6, 7, 8 on the right side, something like that. Try to get you groups of 4. I would like to, I think we'll check to see every group has a document made where everybody is on it. And that'll be, you can get out of here once you've made the document and brainstorm a little bit. Try to write something down. It'll help you drastically to finish the assignment before Friday. So, yeah.
Yeah, and for those on Zoom, I guess if you know your group and you can communicate with them, then do that, or you can write a chat or something. I'll stop sharing for the moment. I think Edward.
Oh, did a lot of people leave?
There were only two.
Okay, you can for Edward, so that you can be with your group. Here, let me see. Are we still okay? Yeah. Look. Wait. We can stop recording. Escape.